All right, here we go. Day 22, Chapter 7, we're going to talk about bivariate data using scatter plots. Bivariate data simply means we have two data sets. Two data sets. Usually we call one X and one Y. Now that's in algebra. In statistics, we call X, this is the X variable, this is the explanatory variable, and Y is called the response variable. Okay, so Y is the response from X. X explains the response. What we usually set up is a linear equation, Y equals A plus BX. Very much the same as Y equals MX plus B from algebra. We'll talk about differences there in a little bit. So, first step when analyzing the relationship between two quantitative numerical things with units variables is to graph the data using a scatter plot. Okay, graph the data using a scatter plot. Your book, if you do the reading, has several nice examples of scatter plots. In the scatter plot, the explanatory variable, which is like the input, it's like your X, should be on the X-axis, and the response, which is the output, the response is the output, which is also the dependent variable. This is the independent. Independent means you get to pick whatever, it's independent from anything. This, you just get to pick your explanatory, or it's the input, okay? And then the output, the response, depends on what you put it in. So that's why the Y is called the dependent. All right, so this should be on the Y-axis. The explanatory variable seeks to explain or predict changes in the response variable. So what we're thinking when we're dealing with two data sets, bivariate data, is that the X is related to the Y. The Y is affected by what happens with the X. And we think that there is some type of association or relation between the two. So the explanatory variable seeks to explain or predict changes in the response. Usually the explanatory variable comes first chronologically, in order, time. For example, when comparing SAT score to college GPA and college GPA, SAT would be the explanatory, since colleges use it to make predictions about how successful students will be in college. You take the SAT before you go to college and can get a GPA. So that's how you know the SAT score is the X. We believe that the SAT score explains how well you're going to do in college. Okay? Each axis should be clearly labeled with the variable's name and unit, and should also have a well-marked and uniform scale on each axis. However, scales do not need to be the same. Okay? The axes often interact at 0, 0, so often intersect at 0, 0, so this would be 0, and then you would have to start at 0 on the x-axis, start at 0 here. But it can actually change depending on the data set. Sometimes it is to your advantage to basically not start at 0, basically to do like a, hey, it's like a little, it looks like a heartbeat thing, and then skip a few and then scale it. Same thing on the X or the Y. And you don't have to draw that, but sometimes it's necessary to scale, like zoom in on a certain portion of your graph so you can see the scatter better. So patterns are often more visible if there is less empty space and the data is more spread out. So if you have data that's in the hundreds on the X and the 300s on the Y, you want to zoom in and start at 100, start in the 300s, so that you're zoomed in on that section, so you don't have a big blank space and then your data is all the way up here. All right, so what we're going to do is you will be graphing scatter plots. You can use your calculator if you want to graph a scatter plot. You should be able to do it by hand as well. Quickly, to graph a scatter plot, you're going to go to Stat Edit. You're going to put your data in lists 1 and 2, your X list, your Y list, and then you can go to Second Stat Plot, and you can graph. Go to your stat plot, turn it on. The scatter plot is that first graph there, and you can just tell it where your data is, and then you can hit graph, Well, I've got some trig function on here, so I better get rid of that, clear that trig function. Now if I hit graph, whoops, now I can graph. I can't see anything, okay? So then you hit the zoom 9, and there's my scatter plot. So that just graphs my x's and y's.
This time, please dismiss students.
All right, so there's our scatter plot. And then if you want to get the values, you can hit trace, and you can move from point to point, and it'll tell you the data points, so then you know how to scale. You do need to still draw a nice scatter plot. It should be well labeled with the scales if you do that, but you can use your calculator to help you out. All right, so there are 4 key features that you have to talk about in a distribution or in a scatter plot. Scatter plot is basically the picture of the relationship between 2 different distributions. Okay, so the 4 key features of a scatter plot are direction, form, and form actually refers to the shape, and we'll talk about different options for the shape, and the strength, and we'll talk about what we mean by the strength here. The strength is more like the spread, the amount of scatter, the spread or the amount of scatter. How far spread out are the points from each other, and then if there are any unusual points or values. Okay, unusual points. Are there any points that are out of the pattern? So, when we're talking about direction, number 1, direction, we always read a graph from left to right. Okay, just like we read a book, just like we read an equation. So you read a graph from left to right. There is a positive association. If the higher values of one variable are associated with higher values of another variable. So here's the x, here's the y. This is getting higher. Left to right is higher. You go small to big, and this is small to big. So if the plot in general moves in an upward pattern as you go from left to right, the points tend to have a general trend of going upward. You would say you have a positive association. You would then come up with, we'll learn how to find what we call a prediction line, a least squares regression line, LSRL. Negative association you could have, a negative association. Higher values of one variable are associated with lower values of another, so it's the exact opposite. When you're low on the x, you're high on the y. So, and then they just go down from left to right. So you'd have a scatter plot that goes down from left to right. You can say that there is no association. If higher values of one variable, like as we move forward on the x, you can't really say, you don't know what's going to happen. There's like just a random pattern. It doesn't matter where you at. You can't really tell, is there a real pattern to this? So no association. All right, the form is talking about the shape of the graph. Now what we are primarily concerned with in stats is a linear form. A linear form, y equals a plus bx, or you could also see it as y equals b sub 0 plus b sub 1x. They're both linear equations. We write it like this in statistics. It means the same, it's just a little bit different format from algebra. The b or the b sub 1 is the slope, and the a or the b sub 0 is the y-intercept where it crosses the y-axis. We'll learn to interpret those things and what they mean. So a linear shape on the x and the y, a linear shape going up or going down. Now this is the only one that we are concerned with for now. Later on in the year we'll talk about nonlinear. All right, so back to our shape, we have nonlinear. Nonlinear we'll get to later on, like very end of the year last thing, because it's not very common that it's on the assessment. So nonlinear, what we want to do is, well, we want to look at our data. It could be nonlinear. So we could have nonlinear shapes. We could have something that goes up like this. The data, the scatter plot, it kind of has a more curved pattern. This would be an exponential function, like an e to the x. You could have something that goes up very slowly and rises like that. I mean, it could go down. You could have a logarithm. You could have quadratic. Okay, quadratic, opening down, opening up. Okay, so you can have other nonlinear shapes. The shapes we will focus on are linear shapes. All right, strength or scatter. The next thing we need to talk about is the strength or the scatter. So there is the amount of scatter is how far away you are from how far away the points are from each other. So this would be like you can have strong, positive, strong, negative, weak, positive, weak, negative. So we go up from left to right, and the points are really kind of tight together, maybe not very far away from what would be a regression line. This is a strong, positive, linear association. Okay? You can have a weak positive, okay? And the same thing would apply to negative. So you can have more spread out, but still having kind of a tendency to go up from left to right. This would be a weak positive association. And we use a specific variable to talk about the strength. The strength of a linear association, only a linear association, is measured with the variable r, and r is referred to as the correlation coefficient. It's very important, and the correlation is a number between -1 and +1, and we'll get all the characteristics in a little while here. So the other thing, so we have the direction, the form, the strength, and now unusual values or unusual points, outliers that fall outside the pattern of the rest of the data, and clusters or gaps in the points are all that are isolated from the rest of the data. We always need to investigate these values. So points that seem to be far away, so outliers would be far away in the x direction or y direction. So far out, like here's an example here. This would be an outlier that's farther in the x and farther in the y, because it's farther away in the x's and above in the y's from the rest of the points. But the thing is, it's not out of the pattern. So we need to just describe the following scatter plots from McDonald's Nutrition Facts. And I'm just going to kind of quickly go over these. You would have to make sure you talk about their shape and stuff in the context of the problem. There are great examples in your book in the reading in chapter 7 that talk about scatter plots. In this problem, we would be referring always to McDonald's and fat versus calories. What we're using here is the amount of grams of fat to predict the amount of calories. We think that if it appears from this graph, so it appears from the first scatter plot, that as the number of fat grams increases, the number of calories tends to increase in McDonald's beef products. Okay, so we would talk about the shape, okay? We talk about the direction, it's positive. And we can talk about the strength then by talking about how far spread out they are. So what you're going to talk about is you're going to talk about the direction. You're going to talk about the form, linear or nonlinear. You're going to talk about the strength, strong or weak. And then you're going to point out any unusual values. So it's kind of like describing data. You talk about the shape, the center, the spread, and unusual values. When you're talking about comparing two distributions, you talk about the similar four things: the direction, the form, which is like the shape, the strength, and unusual values. So for this one, we already kind of talked about it. For this one, I would talk about this differently. This is a salad. We're talking about sodium and fat. We are believing that the amount of sodium might be a predictor, might have an association with fat. And based on this, I really don't see that big of a pattern. So based on my scatter plot of sodium versus fat, I really don't see a whole big direction. Although if you just look at, there seems to be 3 clusters, and that's what probably the most important thing about this data is that there are 3 clusters. And the direction of these, if you kind of connect a pair of clusters at a time, is linear, but together they make kind of a weird, I'm not even sure, but in general it's kind of a positive association, and I would say it's pretty weak. The form could be linear or it could be kind of curved, I'm not really sure, And what's unusual about this is that there are 3 clusters. There are 2 lower clusters as far as fat. So there's a cluster that has low sodium and low fat. There's a cluster that has high sodium and low fat, and then a cluster that has high sodium and high fat. So that's what's really unusual about this. So now this last one is about beverages, and it looks like we've got a lot of different beverages here. We're talking about the fat grams versus the calories. So it looks like the first thing I notice here, the general direction of this is positive. It's fairly strong. It's a little bit spread out here. Fairly positive except for this little line of unusual values. This is like a vertical line here. So I've basically got 2 groups here. I've got groups where there tends to be a positive association as fat increases, the calories increase. That's what this is saying in beverages at McDonald's. But there's this group that has no fat in it, but they still have a high amount of calories. So what would account for those things? Well, these could be like other drinks, milk, and their coffee drinks and that kind of thing, shakes, high fat, high calories. These could be like sodas. Sodas won't have any fat in them, but they'll have from 0 to a lot of calories. So referring to what the variables X and Y are, what the main theme is, not just saying it is positive, strong, associate. You have to refer in context. Alright, so that's enough for the first video. We'll have a second video that will finish up the notes here.